Hi everyone, this video will go through a supervised learning problem using deep learning methods relating to the game League of Legends. The reason why I chose this topic is because I really enjoy playing the game Teamfight Tactics, which is made under the same company as League. However, I couldn't really find any data sets out in the internet, so I did an alternative of it, which is League. The supervised learning problem we are going to look into is the game prediction, given what has happened since the start of the game all the way to the 20-minute mark. The dataset used is the League of Legends dataset sourced from Kaggle. It recorded competitive matches from 2015 to 2017, totaling 7,620 observations. The variables in this dataset include B results, which is whether the blue team has won or lost, goal difference at each minute interval, length of the game, and also variables relating to who and which champion selected in each team at each position. Then on the right, we have some objective related variables, including kill taken details in a list format for each game. The variables of our interest is the result of a team, which is our target variable. Following along to that are objective related variables as our feature variables. And also, it should be noted that goal difference was initially intended to be included. However, it did show quite a high correlation with some of the other feature variables, and thus it's excluded. Now, having an understanding of our data set, we pre-process it so that it can fit into the model nicely. Step one is to clean the data by removing any missing or duplicated values. Then entries with less than 20-minute game length was also removed. In step two, the feature predictors were modified, so a total number of objectives at the 20-minute mark were taken in. An example to that is on the upper right corner. So we can see initially it was in a list format, and there are 2 kills made before the 20-minute mark. And to modify that, we create this new variable named blue team kills, and it equals to 2. Next, the data was standardized and then split into training, validation, and testing set. This is what the pre-processed data looks like, X-train on the left and Y-train on the right. Now onto the deep learning models fitted, and 2 were explored, the first one being a basic neural network. The architecture of the neural network was chosen by the Bayesian approach of hyperparameter tuning. It resulted in a 3-layer neural network, or with leaky ReLU activation function. The first layer has 16 neurons, then the second has 8, and the third one has 8. The output layer has a sigmoid activation function due to a 0 or 1 output for the problem. After fitting it onto the training dataset, it was tested on the validation dataset. The model has a binary cross-entropy loss function of 0.492 and an AUC of 0.84. The other model explored is a convolutional neural network. So convolutional neural networks are well known to be applied on image-related problems. However, it can also be applied onto time series. In our case, the time series is the minute interval of taken objectives. The architecture is a 1D convolutional layer and then goes through max pooling and then the output. This architecture was chosen by the Bayesian approach of hyperparameter tuning. Once again, fitting the model on the training dataset and then testing it on the validation, we obtained results of a loss function of 0.601 and an AUC of 0.81. So with these results, we can compare the 2 models. The basic neural network is actually performing better than the CNN due to the lower loss and lower AUC. This may be due to the CNN taking a bit too much noise from the time series. And that's it for my preliminary results. Thank you for listening.